Boys and girls, this is Mr. Manise here again with a mega exciting video, and in this video we're going to be talking about linear graph characteristics. I know it says linear, it's pronounced linear. I say linear. Linear. Why? Because the first four letters of the word linear they spell line. So your brain processes that piece of information as a line, okay? So I'm going to go through some of these problems here with the linear graph characteristics, but before I jump into that, I do want to talk a little bit about the real world application and how and when we would ever use this stuff, because I feel like a lot of times you guys in math, you see x values and infinity and negative infinity and x-axis and y-axis and all that good stuff, and you're thinking, well, what does this have to do? When would I ever use this stuff? And so you guys know I'm real big on the real world, so I just kind of want to talk through some of the real world application of this stuff. But we're talking about x-intercepts, y-intercepts, positive, decreasing intervals. Is the graph going up? How is it behaving at the end? What's the domain? What's the range and all that good stuff? So I thought I would show you guys just kind of a chart here, and I think I used this analogy in class talking about a stock chart, but a lot of times I feel like it's hard to grasp x-axis, y-axis, infinity. What does all that stuff mean? Well, in the real world, there aren't any infinities and negative infinities and y-axis, x-axis. It's all time and dollars and, cost of goods and all that kind of stuff. But this is a stock chart of Best Buy. This is a 1 year graph of the stock from Best Buy. And all this positive and negative interval stuff and domain and range, you just got to think about it in terms of real world. Okay, well, what has this stock done over the past year? Okay, over here, this is the price per share. Okay, so if I asked you guys, what has this stock done? What has it gone up? Has it gone down? Is it increasing? Is it decreasing? And I would say, well, from here to here, and that's what I want you guys to think about with these intervals. An interval just means I'm just kind of taking a snapshot, like breaking it down by gaps. From this spot to that spot, what's going on with the graph? What has the stock done from this interval to this interval? If somebody asks you, I want you to do it in intervals of 4. You're doing it in sections of 4. So I'm looking at the section of my graph, and I ask, okay, what has the graph done in between there? Well, it's decreased. Over this interval, it's gone down. What has the stock done from this interval to that interval? Okay, well, the stock has gone up. Okay, what has the stock done from this interval to that interval? The stock has gone up. Okay, so that's what we mean when we're talking about these intervals. If I ask you guys, what's the domain? Well, for a long time, okay, it's my x values. Okay, what does that mean? Well, in the real world, we don't have x values. We have time down here. From what to what? That's why we always sweep from left to right. Okay, and I know it's kind of hard to grasp negative infinity to infinity, but on this chart, we're not talking about negative infinity to infinity. I'm talking about real actual dates. If I say, what is the domain for this 1 year chart, I would say, well, my x values are from November of 2015 to September of 2016. That's my domain. These are all of my x values. I'm going from here, from November to here, to September. That is my domain. That is my bracket. That is my window of values on my x-axis, which in this case is time. It's months, okay? What is the range? Okay, that's my y values. Okay, how far down here do I go to how far up here do I go? If somebody asked me what is the range of this stock, I would say, well, it's been at a low of about $25 a share, and it's been at a maximum, a height of about $40 a share. So if somebody asked me what's the range of this stock, I would not say from 40 to 25. I would sweep from bottom to top. That's why we're always talking about sweeping up for the range and sweeping from left to right for your intervals, because that's the way we read a book. That's the way we read a chart. Okay, I'm reading from here, from this date to this date. The range, I'm starting down here at the lowest value to the highest value. If you want to buy something on eBay and you want to look for all the different list of items to buy, they have different options for you, right? You can select lowest to highest. I want you to show me the lowest values first, Mr. eBay, and then I want you to show me the highest values, okay? So that's what we mean, range from bottom to top, domain from left to right, all my x values, okay? All right, so let's go back and start to kind of work through some of these problems. Now, on this on this quiz review here, I've given you guys the formulas up here at the top for the slope-intercept, y equals mx plus b, slope formula, y2 minus y1 over x2 minus x1, point slope, y minus y1 equals m times x minus x1, because in a couple of these problems we're going to have to rearrange our equation to get it in a form where we can start looking at some of these intervals. So the first one, before I start answering these questions on this first problem, I need to do some manipulation here with this equation. I need to get it in the form y equals mx plus b before I start doing the intervals. So the first thing I'm going to do is I'm going to add 5 to both sides here with my equation, and that will give me y equals 2x plus 5. Okay, so that's my slope-intercept form, y equals 2x plus 5. My slope is simply the m. That's my m term right here, right? That's my slope. It's just the coefficient in front of the x. So my slope is 2. That's a rise of run. That means I'm going up 2, right 1, up 2, right 1. So before we answer the rest of the question, let's go ahead and plot this. So on my graph, I'm going to go to a y-intercept. That's my b, my y-intercept. I'm going to go up to a value of 5. 1, 2, 3, 4, 5. And then I like to always go up because I like to think rise over run. Rise means up. Okay, so I'm going up 2. And again, if you wanted to think about this as 2 over 1, I'm perfectly fine with that. That's a rise of 2 and a run of 1. So I'm going up 2, right 1. Now remember, if your slope is positive, you're sloping this way. Okay, my company's making money. I'm going up. I'm rising. I'm increasing. Positive slope. So I'm going up 2, right 1, up 2, right 1. I'm just staircasing up 2, right 1. You could go backwards and you could go down 2, left 1. Down 2, left 1. But I like to always start at my y-intercept and go up if possible if I'm still on the graph on the chart there. And so now we can go ahead and connect our dots here. We can play the connect the dot game. Let's connect our dots. And let's start to answer some questions. Okay, the next one asks for the y-intercept. Well, that's easy. That's always just going to be your b, right? So that's always just going to be this guy. Okay, I'm crossing the y-axis at 0. I always start with the x, 0, and I go up 5. So that's a y-intercept. Now remember, this is an ordered pair, because I see a lot of students make the mistake, y equals 5. I will literally see students write this, y equals 5. Y equals 5 is actually the equation of a line. That's a horizontal line that passes through 5. That's not what we want. We want an ordered pair. So the coordinates of the y-intercept is 0, comma, positive 5. Now the x-intercept, they were mean to us. Okay, they were mean to us on this first problem. If you notice where it crosses the x-axis, it's not a nice pretty whole number. Okay, so you have one of a couple of options when that's the case. You can use your calculator, which I'll show you here in just a minute, for how you find an x-intercept. But another thing you can do is to actually plug in values for x and y and solve for your x and y intercepts. And the way to remember it is you can just remember it's backwards. If I want the y-intercept, I'm going to plug in a 0 for x. If I want the x-intercept, I'm going to plug in a 0 for y. Okay, so in this case, I want the x-intercept. So I need to plug in 0 for y. So I'll plug in a 0 right there for y. So it's going to be 0 equals 2x plus 5, and I need to solve. So I'll subtract 5 from both sides. 2x equals negative 5. Divide both sides by 2, and I get an x of negative 5 halves. So my x-intercept is negative 5 halves, comma, 0. Okay. Now, I don't care with my students. I've told you guys in class, if you wanted to write this as a decimal, I'm perfectly fine doing that. If you want to rewrite that as negative 2.5, perfectly fine. No problem at all if you want to write that. Negative 2.5, comma 0. Perfectly acceptable. Okay. All right, so that's telling me that the x-intercept is negative 5, comma 0, and that's going to help me with the rest of these problems here. Now, increasing or decreasing, how do I figure that out? I like to think about in terms of real world, okay? The graph is going up, yes, but I think about it's increasing, it's got a positive slope. Think about a company if this were time and this were money. The company's making money. As time goes on, the price goes up. Let's go back to our stock graph, okay? This is increasing. What is the stock doing from here to here? The graph, the price is going up, right? So that's increasing. Okay, so the answer to that one's increasing. So the way you guys remember this is if it has a positive slope, it's increasing. If it has a negative slope, my company's losing money. It's decreasing, okay? Now here we go. These are the tough ones. This is pretty much the reason I'm making this video, is because the positive and negative function intervals are extremely difficult. It's just a difficult concept to grasp, okay? So the way that we do this in math class, in ninth grade math class, is we simply look to see where am I above or below the x-axis. I use this silly little analogy in class of, think about the x-axis as water, okay? Where am I above or below water, okay? Now, before I go through this, I'm actually going to digress, and I'm going to break off into a little bit of a tangent here, and I'm going to show you guys why this is so important. Why we learn about these positive and negative intervals. So who cares about this stuff? How would I ever use this in the real world? Guys, I used to use this stuff all the time as an engineer in my previous job. I'm going to show you guys a graph that I just kind of created off the top of my head, but it's very, very similar to a sheet that I used to use when I was an engineer in industry. One of the things that I had to keep track of, I showed you guys a stock chart, okay, money and time, okay. Well, one of the things I had to keep up with as an engineer was how clean the wastewater was that was discharged to the Savannah River, because you don't want to discharge a bunch of pollutants because it's going to kill the fish and the living organisms and all that stuff. It's an environmental nightmare. So we had limits. The plant that I used to work for had limits on how many pollutants, how many pounds of pollutants could be discharged to the river on a daily basis, because if you do it too much, it's going to kill the fish. Well, so the lab would take samples and they would send the results back to us, and you notice here that this is time, and this actually the plant that I used to work for, we did this 3 times a week, okay, Monday, Tuesday, Wednesday, Monday, Tuesday, Wednesday, and we would keep track of how much ammonia or urea or nitric acid or what was the pH of the water, just like if you have an aquarium at home, you want it to be nice and clean so your fish are nice and happy. Well, I would plot this data into a Microsoft Excel spreadsheet, and I would plot the data, and we would have a limit. Notice that the state of Georgia and the U.S. EPA Environmental Protection Division said, "Thou shalt not discharge more than X amount of pounds of ammonia or urea or nitric acid to the river because you're going to kill everything." Okay, so we had this limit that goes straight across the graph. We were not supposed to go above this line. Okay, so I would plot the data and I would see, okay, what's going on here? My boss would ask me, "Hey, how's it going? How are the numbers looking?" I say, "Oh, boss, we got a problem. You know, the numbers are going up. The amount of pollutants." This would be like pounds. The amount, 100 pounds of ammonia, 300 pounds, 500 pounds, 700 pounds, 800 pounds. It's increasing. My graph is increasing as time goes by. On the y-axis, the pounds of ammonia would maybe go up. Okay. Well, let's look at a graph that looks something like this. And this is the kind of stuff, guys, I did all day long as an engineer. So I would plot the data and I would get the results, and I'd plot and say, whoa, what the heck happened here? Okay, we were running along, our water's nice and clean, the fish are happy, everything's fine. Whoa, we got a problem here. We're above the line. We are above the limit. So in math class, we're asking what is the positive and negative interval, and we say, okay, where's it above or below the x-axis? Okay. Well, in the real world, we don't have x-axis. In the real world, we have money and dollars and pounds of ammonia and time, and we have limits, and we have all these. It could be, you know, hospital data. It could be data from a law firm. It could be all kinds of stuff. I had this line that I wasn't supposed to go over. Well, instead of it being the x-axis, this was 1,080 pounds of ammonia. And my boss would come and ask me, well, when did the problem happen? What is the positive interval? From what x value to what x value did this graph go above this threshold? Because we had to go back and find the problem. What happened? And you can look here at this hypothetical spreadsheet from October 7th to October 13th, we had a problem. Okay, that's the interval. So from October 7th to October 13th, that's my positive interval. That's when I'm above this line. Okay, well, what if my graph didn't look like that? Let's say instead of going up and come back down. So what we would do, we'd have to go out and fix the problem, and then, you know, the wastewater, the cleanliness would come back down and everything's fine. But what happens if the graph stayed above here and it never came back down? What would the positive interval be? When am I above this line? And guys, we've been pounding this in class. We only care about the x values. Okay, from what x value to what x value am I above this line? And I would say, boss, we were above this line starting from October 7th, and we never came back down. We are above this line until infinity. Okay, we are sweeping from left to right. Okay, so I just kind of wanted to show you guys that little real-world application and how, we're tying this into when it would be used in the real world, okay? But in ninth grade coordinate algebra math class, we say, okay, when is my line above the x-axis? My positive interval is when am I above this value, okay? So when do I start? If I'm only looking at the x values, I don't start, I'm going to put a big dot there, I don't start to be above water or above $10 a share or above 1,080 pounds of ammonia. I don't get above that line until I reach that x value. Well, what is the significance of that x value? That's our x-intercept. That's that guy right there, okay? So starting at -5/2, okay, or -2.5, however you want to think about it, starting at -5/2 all the way until what? I never go back below this line. Boss, we got a problem. We stay above this line until I hit January, February, March, April, May, June, July, until infinity. So in the x direction, I am above this line until positive infinity, okay? When am I below this line? My boss comes and says, hey, the numbers look good. When am I below this line? When am I underwater? When am I below the x-axis? Well, if I'm sweeping from left to right, I start out here at negative infinity, or to the beginning of time, if you want to think about months. Out here at negative infinity, I'm below water. Okay, I'm under the threshold. The stock is under $30 a share. We're under 1,080 pounds of ammonia. And I don't go above water, I don't go above that threshold until I hit that X value, which in our case, the significance of that spot is -5/2. Okay. Then we'll do some more with the positive negative intervals, but I really want to hammer that point home because I feel like that's a really confusing point for a lot of students. And even in geometry and 10th grade math, we're still talking about these increasing, decreasing positive and negative intervals. But if you can think about it in terms of real world and think about dates, you're sweeping from left to right, January, February, March, and kind of going in that direction, then I think it kind of helps to make sense of what we're doing here. The end behaviors just means how is the graph behaving at the end. Okay, what is the stock doing at the very right end of the graph? What is it doing? Way over here, the graph is going up. So the right end behavior is going up. Well, in math class, we don't say up. We say going towards infinity or go towards negative infinity. So as x approaches negative infinity, as I head this way in the x direction, as this line goes this way, what is my y doing? So as if you want to think about I want to think about two different pins here, okay? As my pin is going that way in the negative x direction, what is this pin doing? This pin is going down, okay? The y values are decreasing. It's going down. So as x approaches negative infinity, the y's are headed towards negative infinity. On the flip side of that, as my x are headed towards positive infinity, as I'm going this way in the positive x direction, notice what's happening with my y values. They're headed up. Okay, so as x goes this way, y is headed that way. So that's going to be headed towards positive infinity. Okay, let's try another one. Let's try one more. How about this one here? I have, let's drop down to the bottom here. Let's drop down to the bottom. Okay, I have y equals -2/3 x plus 2. Slope-intercept form, I'm already in slope-intercept form, so I'm good to go. Y equals -2/3 x plus 2. The slope is going to be -2/3. Okay, so let's go ahead and graph it. So I'm going to plot it. I'm going to start here at my y-intercept of 2. Now here my slope is negative, so instead of going up right, I'm going to go up left. So I'm going to go up 2, that's my rise, and a run of 3 left. So I'll go up 1, 2, and I go right 1, 2, 3. Up 2, right, left 1, 2, 3. 1, 2, 3. Or I can go down 2 and go right 1, 2, 3. I can go backwards. In this case, that's helpful because going backwards, going down the staircase allows me to find out exactly what that x-intercept is, which we need for the intervals. Okay, so there's my line plotted. Okay, now my y-intercept is simply going to be that guy. So that's going to be 0, 2. No issues there. My x-intercept, now in this case, is nice. Okay, it's a nice round whole number. It's 3. So the ordered pair is 3, 0. Is my company losing money or making money? Okay, is the ammonia going up or is the ammonia going down? The ammonia is going down, or water's getting cleaned up. That's a good thing. Decreasing. Okay, Here we go. Here's the tough stuff. Positive and negative interval, okay? So I'm looking at this spot right here where the graph crosses the x-axis at 3, 0. I'm looking to see when am I above water? When am I above $10 a share? When am I above the limit, 1,080 pounds of ammonia? Because if we're above that limit, the state of Georgia is going to come in and fine us $100,000, and that's a big deal. Okay, so I'm always sweeping from left to right. Sweep from left to right. Okay, so I am above this squiggly line. I'm above water from negative infinity out here to the far left. From negative infinity, I'm above. I'm above water, above water, above water, above water, and I don't submerge below water until I hit that x value of 3. So my interval is negative infinity to 3. We're bracketing from here, from negative infinity to here. That's my interval. That's my section. From negative infinity to 3, my graph, my line is above that squiggly line. Where am I below? Well, obviously, I'm going to dip below water starting at 3. Okay, I'm back below 1,080 pounds of ammonia starting at 3 or October 7th or whatever it is, and I will remain below the squiggly line until October 7th, October 9th, November, December, January. I will remain below that line forever. Okay, this line extends on forever. So in the x direction, it's from 3 to positive infinity in the x direction. Okay, because we only care about these x values for the intervals. The end behavior is x goes to negative infinity on the left. My y's are headed up. They're headed towards positive infinity. As x approaches positive infinity, my y's are headed down. They're headed towards negative infinity. Okay. All right, one more, guys, and that'll be it for this video. I want to work through one problem where they give you 2 points and they ask you to fill out all this information. Now here, I'm going to have to use my formulas, okay? Y equals mx plus b. I'm going to have to use my slope formula. The first thing I need to do is find the slope between these 2 points. I'm going to let this be my x1, y1. I'll let this be my x2, y2. So slope is equal to y2 minus y1 over x2 minus x1. So I just plug in the numbers. It's going to be negative 3. Now make sure you write this extra step, guys. Negative 3 minus a negative 1 over x2, which is negative 2 minus a 2. Please take these few extra seconds and write down that extra step. I know you guys are smart enough to do it in your head. Just trust me. The more steps you write out, the fewer mistakes that you will make, and you will minimize those careless errors. So now your brain processes that as a double negative. So now you can say, oh, okay, that's going to be negative 3 plus 1 over negative 2 minus 2. Negative 3 plus 1 is negative 2. Negative 2 minus 2 is negative 4. Negative over negative, guys, is a positive. So that reduces to positive 1/2. 2 over 4 is 1/2, and a negative over negative just cancel. So my slope is going to be 1/2. Now, I need to figure out what the slope-intercept form is. I need the y-intercept. And here's where I'm going to use my point slope that we learned last unit. So y, and that should just be a y. So my point slope equation says y minus y1 equals m times x minus x1. Now here, guys, I can choose either one of my points. I like to choose the point that has the fewest number of negative signs. So I'll choose the first point. So it's going to be y minus, I'm subtracting a negative 1, so here we go. Here's that double negative again, equals the slope. Now what is the slope? The slope is the slope that I just calculated over here. That's the 1/2. So that's going to be equal to 1/2 times x minus x1, which in this case is 2. Now I need to combine my like terms and distribute. That's going to be a y plus 1. Distribute my 1/2 here. That's going to be 1/2 times x is 1/2 x. When I distribute the 1/2 times negative 2, the 2 on the top and the 2 on the bottom cancel, and I'm just left with negative 1. I will subtract 1 from both sides, and I get y is equal to 1/2 x minus 2. So that is my slope-intercept form. So let's go ahead and graph that. I'm going to go to y-intercept of negative 2. My slope is positive, so I'm going up, right. So I'll go up 1, right 2, up 1, right 2, up 1, right 2. And I only need to draw a few points, and I can play the connect the dot game. Draw my line, and my slope is going to be 1 over 2. Rise over run, up 1, right 2. My y-intercept here is just that, guys, 0, negative 2. Okay, now my x-intercept, now in this case, I can see it, okay? And if guys, if you're not sure, it's going to be 3, 0. I'm going to show you a real quick trick that I've shown you in class with the graphing calculator for how you can immediately tell whether or not what your x and y intercepts are and whether or not you're going to have to do it manually by plugging in zeros for x's or y's. If you go to turn your calculator on, press y equals, type in your equation, all right? In this case, it's 1/2 x. So I can just type in 1x divided by 2, that's fine, minus 2. You can graph the line if you want to. And when you're graphing it, my window is a little bit different. I'm going to press zoom 6, zoom standard. That gets me back to a standard window. So this is the same as that line that I just drew here, okay? Now, to find out what my x and y intercepts are, I can go second. See the blue button here? Anything that you want blue, you got to press second. I can press second table right here where my finger is underneath the graph button. Press second table, and this will give you the t-chart that most of the time you guys are having to make on your own, but your graphing calculator does it for you. And I simply look to see where do I have zeros in the x column or where do I have zeros in the y column. Wherever there's a 0 in the x column, that's my y-intercept. Wherever there's a 0 in the y column, that's my x-intercept. So let's scroll down and see if we can find some zeros. Okay, there's 1 0. So wherever x is 0, that's my y-intercept, 0, 2. Already knew that. Let's keep scrolling. There's another 0. Wherever there's a 0 under the y column, that's my x-intercept. Okay, so my x-intercept is 4, 0. Okay. So in this case, I actually wrote that down wrong. I'm glad I looked at that. I miscounted there. That's actually, that spot right there is actually 4. So there you go. Bam, right there, guys. I just gave you another good reason to use your calculator so you can cut out careless mistakes, because even I miscounted when I looked at that. Okay, so if you're using your calculator, you can go right to it and say, oh, okay, that's my x-intercept, 4, 0. Is my company losing money or making money? Okay. It's going up, so from left to right, it's got a positive slope, so that's increasing. Okay, here we go, the tough stuff, positive interval. When does my graph go above 1,080 pounds of ammonia? When does it go above the squiggly line? When do I go above water? When do I go above the x-axis? Starting here at this spot, at that x-intercept of 4, I am above water, okay? So starting at 4, and remember guys, I'm sweeping, sweep, get out your brooms. We're sweeping from left to right, just like you're reading a book. The wave is going from left to right. So starting at an x value of 4, all the way until I hit what? January, February, March, April, May, June, July, blah, 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 all the way until the end of time, right? In the x-axis, in the x direction, I will always be above that line from 4 until infinity, okay? All right, so now where's my negative function interval? Okay, again, sweeping from left to right. Out here at negative infinity, I am below water, okay? Way down here, I'm underneath water. So from negative infinity, sweeping, I'm underwater, I'm looking at the x values. I'm underwater, and I don't poke my head above water until I hit that x value of 4. So from negative infinity to 4, I'm underneath water. In behavior, as x goes towards negative infinity, my y's are headed down, so that's going to be negative infinity. As x approaches positive infinity, my y's are going up, headed towards positive infinity. Okay, so I know this is a little bit longer video, guys, but this is some difficult stuff here with these characteristics. So please feel free to pause, rewind, watch the video again as many times as you need to, and hope you guys enjoyed this video, and we will see you on the next one.